questions of what we did last time? Besides, what did we do last time? Last time we spent most of our time going through the library of functions and just getting everything up to section 1.3 done. And we did word problems. Now we're going to pick up pace because now we're going to start applying what we know. When we say equation of a line, what are we talking about? Oh, actually, no, before we get started here, I want to give you guys a brain teaser. All right. When we say equations of lines, remember, we talked about this earlier. How many different equations of lines are there? What are they? Where do they all start from? If we're talking about lines, what do we have to know about a line? What do you need to have an equation of a line? To find an equation of a line, from now on, I'm simply going to call that EOL. You need one point and a slope. And you're right, who said 2 points? Yes, that is true. If I have 2 points, do I have a slope? Yes, I can find a slope. But this is what you need to find an equation of a line. You need to know the slope of the line, and you need to know a point that the line goes through. So the way we said it earlier, the equation of a line starts with the slope. So every equation needs to have a slope. And what does a slope do? What's the purpose of a slope with respect to equations of lines or graphs of lines? A slope tells you the relationship between one point, from one point to the next point. It tells you the relationship. Remember, if I give you 1 point, if I have 1 point, let's see, this is 1, that's 2. What if my slope is 3/2? And I have a point. How do I find the next point from there? Yeah, I rise how far? I go up 3 spaces. That's what that tells me. And then I go over 2 spaces. There's my next point. I draw a line, and there it is. And then from here, my next point, I go up 3/2 and keep on doing that. So the slope tells me how each of the points in the graph are related. That's why it all starts from there. The first if we multiply both sides by the denominator, if we multiply both sides, we get this. This is our first equation of a line. This is called the point slope form. Can anybody guess why it's called a point slope form? Is there a point in there? So we have point 1 is at x1, y1. Do we have a slope? That's M. Hence, the x1, y1 is the point, and the M is the slope. So that's a point slope. So that's our first formula we learned. Okay, the next one, if you look at your notes from last week or week before, if we take this equation, solve for y, that will give us this equation. Y equals mx plus b. What is that one called? This is the slope. What is this one called? Think about what we have in there. Notice we never talk about there has to be an x and a y in every equation. Yep, because we have a slope and we have a y-intercept. So this one's called the slope intercept form. We have the slope and we have the y-intercept, which is 0, y. That's our second equation. Then from here, move x and y to the same side, we get the third equation. This third method is called the standard form. The only stipulation here is A has to be positive. If A is negative, then just change the signs across the equation. But the leading coefficient, A, has to be positive. So those are your equations. So whenever somebody asks you, find the equation of a line, you have to know which form they're talking about. Each one of these are equations of lines. If it doesn't specify, this is our default. So if it doesn't say use this specific method, then you use the y equals mx plus b. This is our default. All right, let's look at some examples. Example 1. A line has a slope of -7/9 and a y-intercept at 0.16. Find an equation of the line. Find the equation, find an equation of the line. All right, so remember, it says it doesn't specifically say what kind we're going to use. We're going to end up with this one. But which formula would you use to start off with? Because you're given a point and you're given a slope. So you use the point slope. The point slope formula because we're given the point and the slope. So what would I put in place of y? Nothing, because that's just the y. So leave y alone. What's y1? Yeah, this is the x1 and this is y1. So it's 16. M is -7/9. X1 is 0. All right. There you can leave it like that. Is this an equation of a line? Yes. It's the point slope formula. It is an equation of a line. You can leave it like that. It's a valid equation. But we want it to be this one. So what do we have to do with this equation? Well, let's see what we did. Let's see what we did last time. We talked about this way. We had this equation. Then what do? Solve for y, we put it into here. So let's solve for y with this equation. Okay, rule of thumb. We have a fraction in there. Many of us don't like dealing with fractions. If you have fractions and an equal sign, get rid of the fractions. I'm telling you this is to make things easier for you in the long run. Because if we leave it in fractions, then we have to now incorporate the rules of adding, subtracting, and multiplying fractions, which is a lot of extra work. But if we get rid of the fractions, we just eliminate all those extra rules. So to do that, to get rid of the fractions, we have 5 steps. First step is find the LCD. So what is our LCD in this case? What's the only denominator? Yeah, only fraction we have. We have the denominator is 9. That's step 1. Find the LCD. Two, multiply the LCD to each term. What's a term? Again, I want to hear people who don't know anything.
Separated by plus, minus, or equal.
Now, when was the last time you took algebra?
Sure.
When was the last time you took algebra?
Freshman year, class.
Yeah, because you remember pretty well. Yes, a term is anything separated by plus, minus, or equal sign. Because if this is easy for you, don't answer. Again, I don't get impressed by people who know this already. So now we take 9. How many terms do we have here? Anybody in the middle part of the room? Or the back 2 rows? How many terms do we have? What's that? Anybody agree with 3 terms? 3 terms. This is our first term. There's a minus. There's our second term. And there's an equal. This is only one equation here. So we have 3 terms. So we take 9 and multiply it to each term. Well, what is x minus 0? What's that? No.
Well, I think you said X time.
No, it's x minus 0 right there.
X.
Yep, it's just x. All right, third step. The rule of fractions, whenever you multiply fractions, never multiply first. Always reduce first. Always reduce your fractions before you multiply them. So can anything reduce here in the first one? No. In the second? No, there's no fraction. Only thing we can reduce is here. 9 goes into 9 one time. Those cancel. You can only reduce if you have a fraction, a top and a bottom number. So that leaves us 9 times y, 9 times 16. So that's gone. So we have negative 7 times x. At this stage, both of these equations are identical. Which one's easier to work with? The bottom one, which is the whole purpose of this process. Our fourth step is to multiply to remove the parentheses. So 9 times y is 9y. 9 times 16, 9 times 6 is 54. 9 times 1 is 9, plus 5 is 14. Negative times positive is negative. 7 times x is 7x. Remember, whenever you multiply, treat them both separately, signs and numbers separately. Is everybody okay multiplying by 9? Easiest way, like 9 times 6. Hold your fingers up like this. 9 times 6. Put down your 6th finger. What do you have left? 5, 4. It's 54. 9 times 3. Put down your 3rd finger. 2, 7, 27. 9 times 9. Put down your ninth finger. 81. So that's easy with 9s. Who needs calculators? Your last step is solve for y. To get the y by itself, what do you get rid of first? What do you have to get rid of first? If you're solving for y, what do you have to get rid of? 144, yeah. Get rid of anything that's added or subtracted to it. Get rid of plus and minuses first. So how do we get rid of 144? Because it's negative, we have to do the opposite. add 144 to both sides. So it's negative 7x plus 144. Remember, solving for y, what do you do next? How do you get y by itself?
You divide by 9 on both sides.
Right, because we have to get rid of 9. How is 9 connected to y? They're multiplied. So what's the opposite of multiplication? Division. So we divide each one separately. So 9's cancel. We have negative 7 over 9 x. Nine goes into 14 how many times? One time. With how many left over? 9 fits into 14 one time with 5 left over. 9 fits into 54 how many times? You can remember the finger thing? You can do it backwards. Put 5 and then 4. What finger is down? 1, 2, 3, 4, 5. The 6th finger. So 9 goes into 54 6 times. So it's 16. There is your equation of a line that has the slope negative 7 over 9. Going through the point 0, 16. Let's look at another example. Yes.
So we could have just like, skipped it, just plugged it in.
I mean,
Because when we first looked at it, I just thought y equals mx plus b. So I was like, well, they gave you the m and then they said the y-intercept and that's b. Technically could you just,
was it? Yeah, and that's what it gets here. There are two ways you can do it. This is one way. Again, if you're going to learn something that you use all the time. This is the first way. This is the way that they'd want you to use if you use that. But here's the way that you're going to use. Remember, what we had here, we had 0, 16, and we had m equals negative 7 over 9. We want it to become that equation of a line. So the only thing we have to find is m and b. Do we have either of those? Well, we have m for sure. So let's plug this stuff in there. M is negative 7 over 9. What's x? This is x and this is y. The only thing we don't have is b. Let's solve for b. So x is 0. Y is 16. Negative 7 over 9 times 0 is 0. So we have b equals 16. We have b equals 16 and m equals negative 7 over 9. Now we can plug it in there. So our equation is negative 7 over 9x plus 16. Let's do another one. Your slope is negative 2/3, and it goes through the point negative 3, 6. Well, let's change it. Let's make it negative 3 over 5 6. That's the point it goes through. Find the equation of the line that satisfies those conditions. You're looking for a line that has slope -2/3 going through the point, that one. So we know we want this equation. We have M defined. Do we know what B is? No, we don't know what B is, but we do know what X and Y are. So let's plug everything in there. What's Y? M is -2/3. What's X? And then B, we don't know. We have to solve for B. So plug in what you know, let's solve for what we don't know. So we have 6 equals. Can anything cancel here? Can anything on top cancel with anything on the bottom? Anybody? Okay, first off, you have negative times negative is going to be what? It's positive. So we don't have to worry about signs anymore. So here we have a fraction. Since they're multiplied, we have 2 times 3 over 3 times 5. Is there anything that looks the same? The 3's can cancel. The 3's could have canceled here. That's what I'm saying is when you have fractions, can anything on top and bottom cancel? Plus B. So we have 6 equals 2 on top, 5 on the bottom, plus B. Again, we could move things around and you don't need a calculator. Put it up. You don't need a calculator. Remember, it's a fraction. It's the equal sign. So what do we do? What's my LCD? What do I do with the LCD? Multiply it to each term. So it's 5 times 6, 5 times 2 over 5, plus 5 times B. So each of these terms you multiply by the LCD. Third step, reduce. Does anything cancel anywhere through there? The 5's. Well, typically, here's a rule of thumb. The LCD, if it doesn't cancel completely, it should at least be simplified. It has to reduce with the denominators you have in there. That's why it's the LCD. So what we have now is 5 times 6. The 5's are gone, so we just have 2 plus 5 times B. Multiply to get rid of the parentheses. 5 times 6 is 30. 2 plus 5 times B is 5B. Subtract by 2, because we're trying to get B by itself. So we have 28 equals 5B. Divide both sides by 5. So there's your y-intercept. What's our slope? Our slope was negative 2/3. That was given in the equation. So plug them in there. M is negative 2/3 x, and B is 28/5. Okay, yeah, now the textbook, and we enter in the computer, it'll let you put that in there. But in the true rules of mathematics, you never want to leave an answer as an improper fraction. You wouldn't simplify it, you would simply rewrite it as a more conventional term. So, but for simplicity purposes, oh, it's 2/3. How many times is 5 going to 28? With how many left over? So yeah, both of these answers would work. It's just, it's easier for the programmers when they wrote the program to use the improper fraction as answers. So you could do either way. So far, so good? Any questions so far? All right. So that's if we have one equation. What if we have two lines? If you have two lines, what possible connection can they have to each other? This is not an XY graph. This is just, there are four possibilities. If you have two lines, the first thing, here's line 1, here's line 2. Remember, whenever we deal with lines, we look at the equation of the line. Each of these lines have this equation. So what do we notice about these two lines? Will they ever touch? No. What are they called if they never touch? They're called parallel. How do we know they're parallel? Instead of writing parallel, we could use that little symbol there. Now, if they're parallel, what do we know from this equation? What do we know about them? Again, I don't know more. If they're parallel, yes. We have to have the same slope. What else do we know about them? Look at the equation. We have two parts that we have to think about. If they have the same slope, what else can we think about? What does B stand for? Okay, now what about the y-intercepts if they're parallel? Yeah, they have to be different. They have to be different. So the y-intercepts cannot be equal. So if two lines have the same slope, but their y-intercepts are different, think of it this way. Here's the xy on this one. This is your x-axis, this is your y-axis. They have to have different y-intercepts. This is B1 and this is B2. So we know parallel lines have to have the same slope but different y-intercepts. What would happen if they had the same slopes and the same y-intercepts? What would that look like? I see where you're going to try to get to, but no, you're jumping ahead of the gun there. The same line, yeah. Because if two lines had the same slope and the same y-intercept, so line 1 and line 2, they would be the same line. So in the first condition, we're looking at if the slopes are the same. If the slopes are the same, they're either going to be parallel or the same line. So how many solutions will parallel lines have? When we talk about two lines, solutions are where they cross. Solutions are where the lines cross. So how many solutions in parallel lines? No solutions. Because they never intersect. How about the same line ones? Infinite solutions. Every point is a solution. Every point you see is a solution. So if we have two lines, if I give you two equations, two lines, solve them for y, and compare the slopes. If the slopes are the same, then they're either going to be the same line or parallel lines. Okay, now, what if they're not the same? If they form, this is a 90-degree angle. If the two lines form a 90-degree angle, we call those perpendicular. And the shortcut is just upside down T. How many solutions do they have there? They only have one solution. Are the slopes the same? No. So these are going to be, how are they different? Well, here's another example of different slopes. Here's line 1, here's line 2. This is just any other. They're not parallel, they're not perpendicular, they're not the same line, it's just any other lines. How many solutions do they have there? They have one solution. So what do we know? If the slopes are different, then we have to have one and only one solution. If the slopes are the same, either we have no solutions or infinitely many. It's all or nothing on those. So with these, with the any other line, all we know that the slopes are not the same. They're not equal. We don't care about the y-intercepts. Why not? Because this solution can happen on the y-axis, or it doesn't have to happen on. So the y-intercept is irrelevant there. If the slopes are different, then we know we have a solution. Now, here's the tricky part. If they're perpendicular, how do we know they're perpendicular? If the slope of one line is equal to the negative reciprocal of the second line? If the two lines, if the slopes are negative reciprocals, what does that mean? Negative reciprocals. Yes, you guys didn't hear that. When we say negative reciprocals, are the signs the same? No, the signs are different. What does reciprocal mean? Flips. So here, let's look at what this means. I'm going to give you four slopes. I'm going to give you four slopes. You're going to give me the slope of the line that's parallel and the line that's perpendicular. Here's the first one. This line has a slope 2/3. What's the slope parallel to that one? Remember what we said earlier. If they're parallel, what do we know? They have to be the same slope. So if the slope is 2/3, what's the parallel slope? 2/3. The perpendicular slope has two things. First thing, we have to change the sign. And the second thing, we have to flip it. So what's this one going to be? -3/2, right? Because if this is 2/3 positive, I got to change the sign and I got to flip it. That gives me perpendicular. Parallel is exactly the same. Here's number 2. So what's the line, what's the slope parallel to that? Yeah, it's the same. It's -3. What's the slope perpendicular to -3? 1/3, positive. Because -3 is actually a fraction. I changed the sign. This was going to be positive because this was negative, and I flipped the numbers. Everybody kind of okay with that? If they're parallel, it's exactly the same. If it's perpendicular, we have to change sign and flip. If it's parallel, it's the same. All right. And the next one. Fill in the two blanks for me. What's the parallel slope? Very good. It's, yeah, that's the easiest one. If it's parallel, it's just the same thing. What's perpendicular? Which is undefined. Very good. It is one, because this is 0/1. Very good. This one is 0/1. What if I gave you a slope that's undefined? What's the slope parallel to it? It's also undefined. Remember, parallel is the same, which whatever that is, it's the same. Just copy it over. What's perpendicular? That one's undefined. It can't be the same. Why is this one undefined? Anybody? It's what? No, why is this one, why is it called undefined? Why would this one be undefined? What does the slope look like if it's undefined? If it's undefined, it has a 0 on the bottom. So perpendicular, if I flip it, I got 0/1, which is 0. Those last two are thinking ones. And the worst thing about it is you've been drawing pictures of these two all along. What does a graph look like if the slope is 0? Remember, it's these slopes, what's slope face tell you? They're all straight lines. Horizontal, very good. It's a slope equals 0 is a horizontal line. What is it if it's undefined? It's a vertical line. Very good. So if we put those two together, if we have a horizontal line and we put a vertical line through there, what does that look like? The X and Y graph. The slope of the x-axis is 0. The slope of the y-axis is undefined. They're perpendicular. They're perpendicular to each other because they form a 90-degree angle. Okay. Example 4. Here are two lines. Y plus 2 equals 5x and 5y plus x equals -15. This is A. Tell me if the two lines are parallel, perpendicular, or neither. Parallel, perpendicular, or neither. And yes, the reason it's called neither instead of neither, because it's a German word, it came from nieder. In Germany, the E before I has an I sound, so it's neither. That was free information. Any ideas yet? What do you have to do first? Solve for y. Because in order for us to tell if it's parallel, we have to know what the slopes are. We have to put it in this form. I realize I shoot myself in the foot when I say ask you not to do answers, because that takes longer and longer and longer, but it's a catch-22 for me. So if I solve for y, what does the first one give me? What do I do for the first one to solve for y? What's that? Very good. To get y by, I subtract 2. So it's y equals 5x minus 2. Here's line 1. That's line 1. How about the second one? What do I do there first? Subtract what? Very good. Subtract x. Anything that's not connected to y, I get rid of first. So I subtract x from both sides. So the x's cancel. 5y equals negative x minus 15. Then what? Very good. Divide each term by 5. So I have y equals negative x over 5 minus 15 divided by 5 is 3. So this is line 2. To determine if they're parallel, perpendicular, or neither, what do I have to compare? Slopes. So what's the slope of line 1? Was it? Or just 5? Yeah, you say 5 or 5 over 1. They both work. How about the slope of line 2? Very good. Very good. That was a trick question. Because if you have negative x over 5, what number is in front of x? 1. So it's negative 1 over 5x. Same thing. Okay, so now what do we have? Are they parallel, perpendicular, or neither? It's what? Are they the same? They're not parallel then. Do they have, okay, to be perpendicular, are they different signs? Yes, different signs. Are they flips of each other? Yes. So these two lines are perpendicular. We have different signs and they're flips of each other, so they're perpendicular. Two y plus 4 equals 8. And then 5 plus 2x equals negative y. Tell me if they're parallel, perpendicular, or neither. Actually, I'll put the next two up there. So we have 2x plus 1 equals y. Y plus 3x equals 4. Tell me if they're parallel, perpendicular, or neither. When you finish, all right, we have to solve for y. What do we have to do for the first equation? Subtract 4x from both sides. So we have 2y equals, even if you leave it like this, it doesn't matter. Next step. I'm trying to get y by itself. What does it get rid of? Divide by 2 across. So we have y equals 8 divided by 2 is 4. Minus 4 divided by 2 is 2x. So what's the slope of this first one? Remember, slope is always what's in front of the x. So it's negative 2. That's the slope of this first one. Okay, the second equation, let's rewrite, put this over here. So we have, all I do is flip it around. To get rid of this negative sign, what do I do? Just change the signs across the board. -5 minus 2x. So what's the slope of this one? Also -2. So they're both -2s, so what does that tell us? If they're the same, it's what? It's parallel. Okay, this one's already done, really. It's y equals 2x plus 1. What's the slope of this first line? It's 2. To get y by itself, I got to do what? Subtract 3x. Y equals -3x plus 4. So what's the slope of the second one? -3. Are they the same? Are they negative reciprocals? So it's neither. So the hardest part everybody's having there is moving things around. Practice that. That's going to be very important, especially as we move along in this course. Be able to move your equations around. That's very important. All right. Let's put everything together now. Let's put everything together. Example 5. Write an equation of the lines A parallel and B perpendicular to the graph of the line 4y minus x equals 20 and going through the point 2, -3. So it wants you write an equation of a line that's parallel, an equation of a line that's perpendicular to the graph of the line 4y minus x equals 20 and going through the point 2, 3. So we're going to find two equations here. We're looking for equations of lines. What do you need to find an equation of a line? But two things. You need a slope and a point. We have a point. Now we have to find the slope. Where does the slope come from? Well, it's got to be parallel or perpendicular. Can you close the door, please? It's got to be parallel or perpendicular to this line. So how do you know if it's parallel or perpendicular? If it's parallel, what do we know? Has the same slope. If it's perpendicular, it's a negative reciprocal. So we have to find the slope of this line. So the first thing we got to do is take this equation and solve for y. We just add x to both sides. So we have 4y equals x plus 20. Then what? Divide each part by 4. So y is equal to x over 4 plus 20 divided by 4 is 5. Okay, this is our main equation. What is the slope of this equation? No. Slope is rise over what number? What number is in front of x? So it's 1 over 4. That was a tricky question. So now we know the main equation, what the slope is. So now we can figure out, we know the slope parallel is what? Parallel? Yeah, it's the same. So if it's parallel, it's the same. If it's perpendicular, then we flip and change. So change the sign, so it's negative. Flip 4 over 1. So it's just negative 4. So we have the slopes. We have the point. We plug them into the equation. The equation we're going to use is y equals mx plus b. So y equals mx plus b. Well, let me go to the next page. We know the slope parallel is 1/4. The point is 2, -3. And the slope perpendicular is -4. Do we know what y is? This is x and this is y. Do we know what y is? -3. Do we know what m is? M is 1/4. Do we know what x is? X is 2. We just don't know what the y-intercept is. So we got to solve for b. 2 goes into 4 twice, so we have -3 equals 1 over 2 plus b. We have fractions and equal sign, so the LCD is what? We multiply 2 to each term. Reduce, get rid of the fractions. So we have 2 times -3 equals 1 plus 2b. Get rid of the fraction, decimal, or percent, parentheses. Positive, negatives, and negative. 2 times 3 is 6. Equals 1 plus 2b. Solve for b. I have to get rid of the 1 first, so I subtract 1 from both sides. -6 minus 1. They're both negative, so the answer is negative. 6 plus 1 is 7. If the signs are the same, take the sign and add the numbers. Equals 2b. Divide both sides by 2. So B is equal to -7/2. So far, so good? Remember, the slope of this side was 1/4. So plug it back inside here. Plug in your slope, plug in your y-intercept. So your answer is 1/4 x minus 7/2. This is the equation of the line parallel. So that was the answer to part A. Any questions about it?
You're saying this is parallel to the 1/4 x plus 5?
Yeah, no, that's parallel to this one. This is the original line. This line here is parallel to that one. And it goes to this point. How do we know? How do we know that this point is on this line? We'll check that in a second next. So let's do part B. This is part A. This is part B. This one, we use the perpendicular slope. We know what y is. It's -3. We know m is -4. X is 2. We just don't know b. No fractions. That's a good sign. So we get rid of the parentheses. Negative times positive is negative. 4 times 2 is 8. Solve for b, so we add 8 to both sides. B. We have positive and negative. If the signs are different, what do? Take the sign of the bigger number. It's positive, so the answer is going to be positive, and do what with the numbers? If the signs are different. What math operation goes with difference? Subtraction. So now we subtract the numbers. 8 minus 3 is 5. So 8 minus 3 is 5. And we know our slope is -4 because it's perpendicular. Plug everything in there. Here's my slope. Here's my y-intercept. So y is equal to -4x plus 5. This is the perpendicular. So the mechanics are all the same. What's the only difference in these two equations? The only difference is how we found the slope. For the parallel one, we solved the equation for y. We took this equation, solved it for y, and we know the slope. If it's parallel, it's the same. If it's perpendicular, I got to change the sign and flip it. Once I have the slopes and the point, It's all the same from there. These are the same steps. Any questions? How do we know that this point is on these lines? The point was 2, -3. And the first line, the parallel one, was y equals 1/4 x minus 7/2. And the perpendicular one was at y equals -4x plus 5. It's easy. Plug them in there. What's y? -3. And x is 2. Work it out. See if both sides are equal. So we have -3. The 2 cancels with the 4. That makes it 2. So we have 1/2 minus 7/2. What's the rule about subtracting fractions? They both have a common denominator, so they're both 2. So we just worry about the top. 1 minus 7. 1 minus 7. 7 is bigger, so it's negative. 7 minus 1 is 6. 6 divided by 2 is 3. So they're both equal, so that point is on that line. Do the same thing with the other one. We know that y is -3 and x is 2. Plug them in there. See if both sides are equal. Negative times positive is negative. 4 times 2 is 8 plus 5. -8 plus 5, 8's bigger, so it's negative. 8 minus 5 is 3. So there. Those are both valid lines. Does anybody have any trouble adding, subtracting fractions? If I had 1/5 plus 3/5, can you do that? What does it equal? They have a common denominator, so worry about the top. Pretty easy. How about if I had 1/3 plus 2/5? There's no problem with it. We know the answer is going to be a fraction. Create a butterfly. This is called the butterfly technique. Multiply these. 5 times 1 is what? Multiply these. 3 times 2 is 6. This sign here goes in the middle. So on top, we have 5 plus 6. On the bottom, multiply. 3 times 5 is 15. So the answer is 11/15. It's much easier, much faster doing this than getting common denominator, multiply, all too much work. Let's test it on this one again. 1/5 plus 3/5. Using the butterfly method. So whatever signs here goes in the head. Five times 1 is 5. 5 times 3 is 15. So on top, we have 5 plus 15. On the bottom, 5 times 5 is 25. So we have 25 on the bottom. What is 15 plus 5? 20. What do 20 and 25 have in common? 5. So 20 is made up of 5 times 4. 25 is 5 times 5. The 5's cancel. We're left with 4/5. So don't worry, if you ever have to do adding, subtracting fractions, don't worry about it. Just use the butterfly method. It's a legitimate method. I still use it instead of having to worry about, because otherwise, if we had different fractions, let's say 2/3 minus 5/6, or let's say 5/7. What we normally have to do is this one has a 3, this one doesn't, so I need a 3/3 here. This one has a 7, this one needs a 7, so a 7/7. It's just a lot of extra writing. We'll get the same answer, but it's a lot of extra writing. 7 times 2 is 14. 7 times 3 is 21. 5 times 3 is 15. 7 times 3 is 21. So on top we have 14 minus 15 is negative 1/21. As opposed to seven times 2 is 14. 3 times 5 is 15. So we have 14 minus 15. 3 times 7 is 21. So you skipped all this other writing. So I said, use something, well, if you use something that's easy. Don't try to be more complex. We'll have plenty of time for this course later on. Like factoring. When we get to factoring, that's going to take us a lot of time. And I'll show you shortcuts that makes life much easier when it comes to factoring. Any questions?
You apply the same rules, like if it was negative 2/3, you would just say it's positive.
Well, well, good point. If it's negative 2/3 minus 5/7, same thing here. 7 times negative 2 is negative 14. 3 times 5 is 15, and the sign between them is negative. Over 21. So it's negative 14 minus 15 over 21. So it doesn't matter if it signs negative or positive. Whatever sign here goes in the head. So if that's a negative, the whole thing's, the leading term is negative. So it'd be, they're both negative, so the answer is negative 15 plus 14 is 29. I remember I showed a bunch of graduate students this. They thought I invented sliced bread. They never saw this. They said, if I knew this in elementary school, it'd be a different story. So I'm trying to get to a point where you don't need a calculator. If the first thing you think about is grabbing a calculator when you do math, you got a wrong mindset. You have the fastest calculator right there. It just has to be recharged. Any other questions?